Make sure that that's working. All right, so today we're going to start on section 3.5. And then we're going to finish the second half of 3.6 because 3.5 covers the derivative of trig functions, and the last half of 3.6 covers the derivative of trig functions using the chain rule. So they're pretty much connected. So the derivative of trig functions. Okay, so the first one is that the derivative of sine of x is equal to cosine of x. And the second one is that the derivative of cosine of x is equal to negative sine of x. Here we go. Okay, now we're going to prove the first one, and the proofs are a little bit lengthy, so we're only going to prove that one. The rest of them are pretty closely related, so the proofs are similar. So let's say if we prove that the derivative of sine of x is equal to cosine. Okay, so if we have the derivative of sine of x, we can convert that to a limit definition. Remember, that's the limit as h approaches 0 of f of x plus h. So that's going to be sine of x plus h minus f of x, so minus sine of x, all divided by h. Okay, now that sine of x plus h, we can convert that using the sum formula from your trig identities. Okay, so we know that. I'm just going to put a little box around this. That's a little side note. The sine of x plus h is equal to sine of x times cosine of h plus cosine of x times sine of h. That's the sum trig identity. And you should remember that from either trig or pre-calc. Like I said, if you don't, that's normal because it's not a formula you use all the time, but it does come in handy. So that means we can take that sine of x plus h and just replace it with all that. That's going to equal the limit. Instead of sine of x plus h, we can say sine of x. Actually, I'm going to switch these around because I'm going to have to do that anyway. So cosine of x sine of h plus sine of x cosine of h. So I'll just switch those two terms around. Minus sine of x all over h as h approaches 0. Okay, so for these last two terms, we're going to factor out negative sine of x. Oops, clean that up a little bit. Okay, so we factor out negative sine of x from those two terms. That gives us the limit as h approaches 0, cosine of x times sine of h minus sine of x. And if we factor out this negative sine of x, that turns this into positive 1. If we factor out a negative sine of x here, that's negative cosine of h. So we're just going to flip those around and make it 1 minus cosine of h. All divided by h. Okay. So because we have two terms in the numerator, we can split this one quotient and create two different fractions with the same denominator. So we can have the limit as h approaches 0 of cosine of x times sine of h divided by h minus the limit as h approaches 0 of sine of x times 1 minus cosine of h divided by h. Okay, so this cosine of x right here, we can go ahead and just factor that right out to the front because we're just going to be plugging in the value of h approaches 0. Same with this sine of x. We're only changing the h value, so we can just factor that out to the front. Okay, so that gives us cosine of x times the limit as h approaches 0, sine of h over h minus sine of x times the limit as h approaches 0 of 1 minus cosine of h. And make that h a little bit neater. Cosine of h divided by h. Okay, so if you remember, for these two, these are your special trig identities that we learned a little while ago, or a few sections back. That's the limit of sine of x over x as x approaches 0 is equal to 1. But in this case, only thing changed is the h. So that's still just cosine of x times 1. The other special trig identity was the limit as x approaches 0 of 1 minus cosine of x divided by x, but all we did was change x to h. Same thing applies. So we know that limit is equal to 0. So this is minus sine of x times 0. So we kind of draw a little separator around that one. Well, 0 times anything is 0, so that disappears. So we're left with cosine of x times 1, which is just cosine of x. So we know that the derivative, bring that down a little, derivative of sine of x is equal to cosine of x. Okay. So you don't have to go through all of that. You just have to remember that part. Over a little bit. There we go. All right. Anyone still writing? Okay. Okay, so let's say, for example, we want to find the derivative of, let's say, for problem A, f of x is equal to 2 times sine of x. And for problem B, g of x is equal to sine of x divided by 2. Okay, so for problem A, you know that f of x is equal to 2 times sine of x. That means the derivative of f of x is equal to 2. We can just factor that 2 out, times the derivative of sine of x. Okay, well, we know the derivative of sine is cosine. So that means that our derivative f prime of x is equal to 2 times cosine of x. Little side note there. Oh, yes.
It always changes the cosine. Like,
Yep, whenever you have the derivative of sine, it always changes to cosine. And the same thing with B. We have g of x is equal to sine of x divided by 2. I'll just write that as 1/2 times sine of x. So that means if we wanted to find the derivative That's just 1/2 times the derivative of sine of x. Okay. So again, we know the derivative of sine of x is cosine of x. So we know our g prime of x is equal to 1/2, and that just turns into cosine of x. Right. Any questions on that one? Okay. Let's do one with cosine. Okay, so what if we want to find h prime of x when h of x is equal to x plus cosine of x? Okay, well, we know that h prime of x is just the derivative of each term, so that's going to equal the derivative with respect to x of x plus the derivative with respect to x cosine of x. Okay, well, we know the derivative of cosine equals negative sine of x. So that means our h prime of x is equal to the derivative of x with respect to x is just 1, plus the derivative of cosine is negative sine. So we just replace that with negative sine of x. So since we have plus negative, we can just go ahead and make this minus sine of x. So h prime of x is equal to 1 minus sine of x. All right, anyone still writing? Okay. So what if we wanted to find the derivative of f of x is equal to negative cosine of x plus sine of x at the point x equals negative pi over 2. Okay. So we know that our f prime of x is just equal to the derivative of negative cosine of x. And we can factor out that -1. You can put negative or -1, whichever one is more comfortable for you. So -1 times the derivative cosine of x plus the derivative of sine of x. Okay, so if we simplify each term, this is -1 times the derivative of cosine, which is negative sine. So we replace this derivative of cosine with negative sine of x, plus the derivative of sine, we know that's cosine. So we replace this with cosine of x. So since you have -1 times negative sine of x, negative times negative is positive, so we can rewrite that as our derivative is equal to sine of x plus cosine of x. Okay, so we're almost there. Okay, now at the point -pi/2, we just plug that into our derivative. So f prime of -pi/2, that's just going to equal sine of -pi/2 plus cosine of -pi/2. And draw a little rectangle around that. So sine of -pi/2 is just -1. So we know f prime of -pi/2 is equal to -1 plus cosine of -pi/2 is 0. So we can just go ahead and replace those with their values. So f prime of -pi/2 is just equal to -1. Okay. Now remember, this question could be worded a bunch of different ways. They could, I'll move it back up in a second, they could write it all out like this, or they could just say find f prime of -pi/2, or basically find this, and it would be the exact same thing. Or they could say find the slope of the tangent line at -pi/2, and it would be the exact same thing. So the derivative has a bunch of different names and a bunch of different uses. All right, any questions on that one? All right, anyone still writing? Okay. Okay, let's say, for example, if we wanted to find the derivative of f of x is equal to -2x to the third power minus x squared plus x minus 2 times cosine of x. Okay, so with this one, you have two functions of x being multiplied to each other. And you're looking for that derivative. So we have two functions of x being multiplied to each other, and you're looking for the derivative. You want to use the product rule. Now, if you wanted to, you could distribute cosine of x to each term, but then you'd have to end up using the product rule for this term, then using the product rule again for this term, then using the product rule again for this term. So you create more work distributing the cosine to each term. Okay, so let's say we have f of x is equal to h of x times g of x. Okay, so again, you can call it h of x equals f of x times g of x. That the actual variable used doesn't matter. So that means using the product rule, when you're multiplying two functions, remember it's the first function times the derivative of the second plus the second function times the derivative of the first. And we'll kind of separate that a little bit. That's more of a note than anything. That means your derivative, let me move this over a little bit more. Your derivative f prime of x is going to equal the first function. So negative 2x to the third power minus x squared plus x minus 2 times the derivative of the second function. So times the derivative of cosine of x plus the second function, which is cosine of x, times the derivative of the first function. So that's times the derivative of negative 2x to the third power minus x squared plus x minus 2. And that's just if you call this your h of x and this your g of x. Okay, so that means our f prime of x is equal to negative 2x to the third power minus x squared plus x minus 2 times the derivative of cosine, which is negative sine. That's times negative sine of x. So that just became that. Okay, plus cosine of x times the derivative of negative 2x to the third power minus x squared plus x minus 2. So we have negative 2 times the derivative of x to the third power. So using the power rule, we bring that 3 down. So negative 2 times the 3 we brought down was negative 6. Well, is negative 6. Times x to the power of 3 minus 1, which is squared. Minus the derivative of x squared. Again, using the power rule, we bring down the 2. So that's 2x to the power of 2 minus 1, which is the first power, so we can just leave it like that. Plus the derivative of x with respect to x, which is just 1. Minus the derivative of 2. Well, we know the derivative of a constant is always going to be 0, so that would just disappear. Okay, so this negative 1 in front of the sine x, we can just kind of factor that right out to the front. So we have f prime of x is equal to negative, or you can just put negative sine x right there if you wanted to, times negative 2x to the third power minus x squared plus x minus 2 plus cosine of x times negative 6x squared minus 2x plus 1. And you should be just fine like that. You don't have to distribute the sine or the cosine. Or you can flip these two and just make it cosine of x times negative 6x squared minus 2x plus 1 minus this. But again, that's the exact same thing, so it's completely up to you. So you can make it cosine of x times negative 6x squared minus 2x plus 1 minus sine of x times negative 2x to the third minus x squared plus x minus 2. I don't believe Newton would make a difference between the two, but you never really know. All right. Are there any questions on that one? All right. Anyone still writing? Okay. Excuse me. All right, so let's say, for example, let's say we wanted to find h prime of x when h of x is equal to negative 5 times cosine of x divided by x to the third power minus 2x squared minus 4x minus 1. So again, just me personally, I always try to factor out any constants that I can. So I'm just going to factor out that negative 5. Doesn't do a whole lot, but makes it a little bit simpler. Times cosine of x divided by x to the third power minus 2x squared minus 4x minus 1. So now we apply the quotient formula because we have a quotient with a function as our numerator and a function as our denominator. Okay. So remember the derivative of the quotient rule. And let's say, just to put a little side note, say h of x is equal to f of x divided by g of x. So we just made our numerator f of x and our denominator g of x. So remember, the quotient rule is the denominator times the derivative of your numerator. I'll just put f prime of x. Minus the numerator times the derivative of your denominator all over the denominator squared. So that's your g of x squared. Remember, this is your quotient rule. For derivatives. Or your quotient rule formula. So that means that your derivative, h prime of x, is going to equal that -5 that we factored out. Okay, so you have your denominator times the derivative of your numerator. So that's going to be x to the third power minus 2x squared minus 4x minus 1 times the derivative of cosine of x minus your numerator times the derivative of your denominator. So that's times the derivative. Will I have enough room? I should. X to the third power minus 2x squared minus 4x minus 1. Ooh, close call. All divided by your denominator squared. So that's x to the third power minus 2x squared minus 4x minus 1 squared. Okay, so if we simplify each term, it's -5 times your numerator is x to the third power minus 2x squared minus 4x minus 1 times the derivative of cosine, which is negative sine. So times negative sine of x minus cosine of x times the derivative of x to the third power minus 2x squared minus 4x minus 1. Okay. So the derivative of x to the third power, we bring down the 3, times x to the power of 3 minus 1, so that's 3x squared, minus the derivative of 2x squared, so we bring down the 2, so that -2 times 2 is -4, times x to the power of 2 minus 1, which is just the first power, so we can leave that, minus 4 times the derivative of x. Well, we know the derivative of x is just 1, so that's -4 times 1, which is -4, minus the derivative of 1, which is 0, because the derivative of a constant is always 0. All divided by x to the third power minus 2x squared minus 4x minus 1 squared. Okay. So if we distribute this -5 to this first term, and we distribute this -5 to this second term, that's h prime of x is equal to, and if you want, because this is positive, you could move that one to the front and negative, make that second term, but you don't have to. That's -5 times x to the third power minus 2x squared minus 4x minus 1 times sine of x, or you can just make it -5 sine of x. Completely up to you. Let me just erase that instead of trying to squeeze it in there. So -5 sine of x times x to the third power minus 2x squared minus 4x minus 1 minus, distribute that -5, so that becomes plus 5 times cosine of x times 3x squared minus 4x minus 4, all divided by x to the third power minus 2x squared minus 4x minus 1 squared. And this is really as far as you have to go. You don't have to simplify it any more than that. At least I wouldn't. You can, but once you get it here and it's correct, you don't have to take it any further. That x is a little messy. Let me clean that up some. There we go. Yes.
When you multiply the negative 5 by the negative sign of x, wouldn't the negatives cancel?
Only if you distribute it to each one of those terms.
Okay.
Yeah, but if you leave it factored out, then you can just leave it as negative.
Okay.
All right. Anyone still writing? All right. So let's look at the remaining derivatives. We have the derivative of tangent of x. And that's equal to secant squared. We have the derivative, and make that x a little neater, of cotangent of x, which is equal to negative cosecant squared. We have the derivative of secant of x, which is equal to secant of x times tangent of x. And we have the derivative of cosecant of x, which is equal to negative cosecant times cotangent. Okay, so one thing, if you notice, the derivative of all the cofunctions are negative. Derivative of cotangent is negative cosecant squared. Derivative of cosecant is negative cosecant cotangent. The derivative of cosine is negative sine. So those are the only ones that are negative. That just kind of gives you something to notice when you're writing out your derivatives, that the cofunctions are the negative ones. Okay, now these derivatives really aren't that bad as far as proofs go, so we'll prove the derivative of tangent equals secant squared. Now there is a method where you can do the tangent of x plus h minus tangent of x all over h, like we did the last one. That's the long version of the proof. The shorter version of the proof is the one I'm going to do here because it gives you the same result with a little less work. So we have the derivative of tangent of x. Okay. Well, we know that equals the derivative with respect to x. And we can replace tangent of x with sine divided by cosine, since sine divided by cosine is equal to tangent. A little side note. Tangent of x is equal to sine of x over cosine of x. Okay. Now, since we're finding the derivative of a quotient, we can just use the quotient rule. Okay, so we know that's equal to your denominator times the derivative of your numerator minus your numerator times the derivative of your denominator all over your denominator squared. Okay, so we have cosine of x times the derivative of sine, which is cosine. So cosine of x times cosine of x minus sine of x times the derivative of cosine, which is negative sine. So we replace that derivative of cosine of x with negative sine of x, all divided by your denominator squared, which is cosine of x squared. Okay, so cosine times cosine is cosine squared. Negative sine of x times negative sine of x is positive sine squared of x divided by cosine squared. Okay, well, if you remember, sine squared plus cosine squared is equal to 1. So we can make that 1 over cosine squared of x. Okay, but we also know that 1 over cosine is equal to secant. Secant is just the reciprocal of cosine. So 1 divided by cosine squared would be secant squared. So that's how we know the derivative of tangent of x is equal to secant squared. And again, the other proofs you can kind of do the same way. All right, anyone still writing? All right. Okay, so let's say, for example, we wanted to find out what is the derivative of f of x is equal to 3 times cosecant of x minus 5 times secant of x. Excuse me. Okay, well, we know that our f prime of x will just equal the derivative of each term. So that's just 3 times the derivative of cosecant of x minus 5 times the derivative of secant of x. Okay, so that means your f prime of x is equal to 3 times the derivative of cosecant. So we replace that with negative cosecant cotangent. Well, cosecant times cotangent of x. Minus 5 times the derivative of secant of x. You know, the derivative of secant is just secant times tangent. I'm about to write out the whole word secant for some odd reason. Here we go. So this derivative we just replaced with that, and this derivative replaced with that. Okay, so now we can just simplify it by factoring out that -1. So our derivative is equal to -3 times cosecant of x times cotangent of x minus 5 times secant of x times tangent of x. All right. So let's say if we have to find the equation of the tangent line. So let's say you want to find the equation of the tangent line. So the graph of f of x equals cotangent of x at x is equal to pi over 4. Okay, so here's a little hint. Whenever you see a problem and it says find the equation of the tangent line, okay. All that means is that you're going to use the point slope formula. And give that a little more room. Okay, so remember that formula was y minus y1 is equal to your slope times x minus x1. But This slope is just your slope of the tangent line times x minus x1. Okay, now that x1, y1, that's your point. And your slope of the tangent line, remember, that's just your first derivative. Okay, so this is more of a little note. So we can kind of separate that from actually solving the problem. Okay, so first thing we're going to do is we're going to find our x1, y1. And you can go in whatever order you like. This is just my particular order preference. Okay. Well, we already have 1 point. That's our x1. That's pi over 4. Now to find our y1, our y number 1 is just equal to f of x number 1. Because y is equal to f of x. Now our f of x is cotangent of x. So this is just cotangent of your x number 1. Okay. So in other words, this is just cotangent of pi over 4, which is equal to 1. Okay, so we have our x number 1 and our y number 1, which is equal to 1. Or you can just write it in ordered pair form if you want. Okay, so we have our point. Now we have to find our slope to use our point slope formula. Oops. Find the slope at x is equal to pi over 4. Okay, well, the slope of our tangent line is just our first derivative. Which is the derivative of our cotangent of x. And we know the derivative of cotangent is negative cosecant squared. So we know our slope of the tangent line is negative cosecant squared. Now at pi over 4, That's just negative cosecant squared pi over 4. Which is negative 2. The slope of the tangent line at pi over 4 is just equal to negative 2. Okay, I'm trying to see if I can fit it all. I'll do it on the next page. I was going to try and fit it all on that page, but I'd rather just write it out neatly. All right, anyone still writing? Okay. Okay, so if we go back to our point slope formula, we just have to plug in everything that we know. Oops, I'll put that down later. So y minus y1, we know our y number 1 is 1. There we go. Is equal to the slope of the tangent line, which is negative 2, times x minus x number 1, which is x minus pi over 4. We've got x. Then at this point, you just have to solve for y. So we distribute that negative 2. So y minus 1 equals negative 2x. Negative 2 times negative pi over 4 is positive pi over 4, where you can simplify it to pi over 2. So if we add 1 to both sides, we have y is equal to negative 2x plus pi over 2 plus 1, where you could replace that 1 with 2 over 2 just to get common denominator. And again, they might take it like that, so I'd try to plug this in first. But if they don't, we just combine those two. Negative 2x plus pi over 2 plus 2 over 2, where these two now have the same denominator. So its simplified form is negative 2x plus pi plus 2 over 2. And again, they should take this form. This is only if they don't. All right. Are there any questions on that one? Okay. So again, they just love equation of the tangent line problem. So if you'll probably see those over and over again. All right. So let's look at higher order derivatives. Okay, so what if we let f of x equals sine of x? Excuse me. Kind of separate that a little bit. So let's look at the first derivative. We know f prime of x is equal to the derivative of sine of x. Which means that f prime of x is equal to cosine of x. And remember the notation, it really doesn't matter which one you use, but you might see different ones. So you might see the first derivative is equal to f prime of x. So let's look at the second derivative. Well, the second derivative of x is just the derivative of the first derivative. So that's just the derivative cosine of x. So we know the second derivative of sine of x is equal to negative sine of x. Okay. Now the second derivative notation kind of looks like this. Second derivative with respect to x. Or you might just see that notation. Now the third derivative, and clean that up a little. Has the three little quotation marks up there. And that's just the derivative of the second derivative. So that's just the derivative of negative sine of x. Okay. So remember, that's just -1 times the derivative of sine, which is cosine. So our third derivative is equal to negative cosine of x. Now that notation looks just like the squared notation, or the second derivative notation. Oh, why did I put a 2 there? I meant to put a 3. Which is the third derivative. Okay. Now, anything above the third derivative, you're no longer putting the 3 quotation, not quotes, yeah, I guess you can call them quotation marks or apostrophes. Okay. Anything after the third, you're just putting the number of derivatives in quotes in parentheses. Make that there we go. fourth derivative is just f with a little 4 up there of x. And that's the derivative of negative cosine, or the derivative of your third derivative. And the derivative of a negative cosine is positive sine. And that notation is the exact same, but you have a 4. And it keeps on going. We'll just put etc. because it keeps on going and going and going. So if you wanted to find the 50th derivative, it's just f with a little 50 in parentheses of x. Okay. So again, you can do that to any, let's say, the nth derivative. Okay, and this is just a notation for the nth derivative. Where n is just some finite whole number. Make that n a little clearer. There we go. Okay. So if you notice, you start at sine of x. First derivative, second derivative, third derivative. The fourth derivative, you end up right back at sine of x, and you start all over again. So really, it's just that continuous cycle. When you get to the fourth derivative, you go back to sine of x. Fifth derivative, you'll be cosine of x. Sixth derivative, seventh derivative, eighth derivative, 9, 10, 11, 12, 13, 14, 15. So it's just that constant rotation of every 4 derivatives, you end right back up at sine of x. And it's pretty similar for cosine, too, if you do the same thing. Every fourth derivative, you have that, where you're right back at cosine, if you had your f of x equal cosine of x. Yes.
So is there like anything like imaginary numbers? Because like I know imaginary numbers, if they're like to the fourth, then after that it keeps going back to the.
Yep. Actually, the process is pretty similar to that. Yeah, process is pretty similar to that one. Almost exactly the same, really.
Gotcha. So if it's like for imaginary numbers, if it's to the eighth, you can just bring it back to like the fourth. It's the same thing as saying to the fourth. So
Yeah.
if the derivative was 8, then it's the same thing as saying it's.
Yep.
4.
That's it.
Okay.
Yep. Same exact process.
Gotcha.
Okay. So let's say if we wanted to find the nth derivative. Yep. So again, if you remember the complex numbers and finding the if complex number, it's the exact same steps. So first thing you want to do is divide your nth derivative by 4. Okay. Your second step, you're going to rewrite it as that nth derivative is equal to 4 times some constant that we will call k plus r, where that k is a constant and that r is your remainder. Okay, so you're going to rewrite your nth derivative of sine of x as the derivative of 4 times some value k, because we know that every fourth interval or iteration, it becomes sine of x. Plus, whatever your remainder is, you're going to do r more derivatives. Okay, so if your remainder was 2, you're going to do 2 more derivatives, because we know that this is just going to be sine of x. Okay. Now, if your remainder is equal to 0, then your nth derivative just stops here. It's sine of x. Right. So let's say, for example, we want to know what is the 49th derivative of f of x equals -4 times sine of x at the point, bring that down a little bit, x is equal to pi. Okay, so remember your first step. You're going to divide the nth derivative by 4. Okay, so it's the 49th derivative. So we're going to take 49 divided by 4. Okay, 4 goes into 4 once. 4 times 1 is 4. Subtract. That gives us 0, so bring down the 9. 4 goes into 9 twice. 4 times 2 is 8. We subtract and end up with remainder 1. actually, we can do the first and second step together, because now we're going to rewrite it. So we have 49 is equal to 4 times 12 plus 1. And remember, that's your n is equal to 4 times some number k plus your remainder. Okay. Now, for the third step, we know that our 49th derivative of x is just the, oh, there it is. You have -4 times sine of x. So that's just -4 times the 49th derivative of sine of x. Okay, so we're going to rewrite that as -4 times, now the 49th derivative, that's the 4 times 12 derivative. Or you can just say 48, but I'll put 4 times 12. Plus, the remainder is 1, so that's plus 1 more derivative. Okay, so we know that this is sine of x. So if we take sine of x and apply 1 more derivative, derivative of sine is just cosine. So that's -4 times cosine of x. So we know that our 49th derivative, oh, made that a little too long. Is -4 times cosine of x. Now, if you had a remainder of 2, then you'd have had 2 more derivatives. Then it would have been negative sine of x. If you had a remainder of 3, it would have been negative cosine of x. If you had a remainder of 4, it would have just been, actually, it shouldn't have been a remainder of 4 because you only have a divisor of 4. So your remainder can only be 0, 1, 2, or 3. Okay, so now we have to find the derivative at the point x is equal to pi. So at x is equal to pi, we know that the 49th derivative, oh, made that a little too big. At pi is equal to -4 times cosine of pi. Which is -4 times the cosine of pi, which is -1, which is equal to 4. All right. So we'll do one more example, then we'll finish up 3.6 that we started yesterday. So what is the 43rd derivative? Of f of x is equal to negative sine of x. At the point, x is equal to negative pi. So if you remember the first step, we're going to divide our nth derivative by 4. So that gives us 43 divided by 4. Okay, 4 goes into 4 once. 4 times 1 is 4. We subtract. It gives us 0. We bring down the 3. 4 doesn't go into 3. So we put a 0 above that. Nothing else to bring down, so we're done. Which takes us right to our second step, where we rewrite 43 as 10 times 4. Or you can say 4 times 10. I'll do 4 times 10. Plus your remainder of 3. And that's just in the form n is equal to 4 times k plus r. So that means we know that our 43rd derivative is equal to the 40th derivative, or you can just say 4 times 10 derivative, of sine of x, plus 3 more derivatives. Well, we know the 4th iteration of sine of x, that's just going to be sine of x. So if you have sine of x, the 3rd derivative of sine of x, oh, where did I put it? Ah, here it is. We know that's negative cosine of x. That means, oh, I forgot something. Forgot to be a negative in front of that sign, so I factored out that negative 1, so we have to put a negative here. So that 43rd derivative is equal to negative cosine of x. Okay. Now a shortcut to that is, once you divide, you can kind of ignore this 4 times whatever, because it's all going to rely on your remainder. So if you, where is it? Where's that last one? Ah, here it is. So if you look at the previous one, since the remainder was 1, it was just the first derivative, which is cosine of x. And on this one, since the remainder is 3, it's just the 3rd derivative, which is negative cosine of x. So whatever your remainder is, that's the derivative you're going to use. So you're going to replace that sine of x with that 3rd derivative. Okay, so we know the 43rd derivative. You have negative cosine, which is just positive cosine of x. Okay, so we have the 43rd derivative. Now we have to find it at the point x equals negative pi. So the 43rd derivative, at negative pi is equal to cosine of negative pi, which is negative 1. All right. Are there any questions on that one? Gonna need some more paper. Here we go. All right. So we can go ahead and finish up section 3.6. Excuse me. Oops. Over here. This is from last class. There we go. Okay. Oh, put that. There we go. Now, section 3.6, from where we left off yesterday, involves a chain rule for trig functions. So it kind of leads right from 3.5. Okay, so if you remember, I'm just going to post all of the trig derivatives. We know that the derivative of sine is cosine. Make that a little clearer. There we go. We know that the derivative of cosine is negative sine. We know that the derivative of tangent is secant squared. And I'll put the other three right next to them. We know the derivative of cosecant is negative cosecant times cotangent. We know that the derivative of secant is secant times tangent. And we know the derivative of cotangent is negative cosecant squared. Okay. Now, these are just the derivatives if you're dealing with just x. So what if instead of just x, you had sine of 7x to the third power plus 4x plus 5? Okay. So that means that x is now a completely different function of x. So if you have the derivative of sine of g of x, or some function of x, and make that s a little clearer, it's still cosine of g of x. But then you're going to multiply it by what's inside, which is g prime of x. It's the only difference between the two. And really, it would work for this also, because it's sine of x. The derivative of that is cosine of x times the derivative of x, which is just 1. So this applies to this also, but it's just easier to remember this than that times 1. Same thing with the derivative of cosine of x. Oh, not cosine, cosine of g of x. That's equal to negative sine of g of x times the derivative of what's inside. Okay. Same thing with tangent. The derivative of tangent of g of x is equal to secant squared of g of x times the derivative of your function. So you can probably see where the whole pattern is going. We have the derivative of cosecant of g of x equals negative cosecant of g of x times cotangent of g of x times your g prime of x. Same thing with the derivative, bring it up a little bit, of secant of g of x. We know that's secant of g of x times tangent of g of x times your g prime of x. And same thing with your derivative of cotangent of some function g of x. That's equal to negative cosecant squared of g of x times g prime of x. So for all the derivatives involving the chain rule, nothing changes except multiplying it by the derivative of your g of x. Move that over a little bit. Okay, so let's say, for example, we wanted to find the derivatives. Okay, so let's say for problem A, we have h of x is equal to sine of 2x. Let's say for problem B, we have g of x is equal to cosine of x minus 1. And C, you have f of x is equal to tangent of 3x. Okay. Now for A, you want to remember that the derivative of sine, and I'll just match up instead of putting g of x because we have a g of x here, I'll sine of h of x is equal to cosine of h of x times the derivative of that h of x. I don't know if I should put h of x since this is h of x. I'll change that from h of x because I don't want to mix that up. Which variable should I use? I'll just use g of x. I'm overthinking this a little too much. I'll change it for B. Instead of using g of x for that one, I'll change it. All right, so for A, we know that our derivative is going to equal the derivative of sine, which is cosine. So it's going to be cosine of 2x times the derivative of 2x. So it's going to be cosine of 2x times 2. Or in most cases, you can just bring the 2 out to the front. That's 2 times cosine of 2x. Okay, same thing for B. We know that the derivative of cosine, and I'll use f of x since B is g of x, cosine of some function of x is equal to negative sine of that function of x times the derivative of that function. Okay, so we know that g prime of x is going to equal the derivative of cosine is negative sine. That's going to be negative sine of x minus 1 times the derivative of x minus 1. Okay, so you take the derivative of the whole thing and multiply it by the derivative of what's inside. Okay. Well, the derivative of x minus 1 is just 1. Because the derivative of x is just 1, and the derivative of 1 is just 0. So 1 minus 0 is 0. So that means your g prime of x is negative sine of x minus 1 times 1, but you could have left that off and just left it, but this is more for visual aid. So that just tells us that our g prime of x is equal to negative sine of x minus 1. Make that one a little bit neater. And kind of the same thing for c. We know that the derivative of tangent, and I'll use g of x for this one, is equal to secant squared of g of x times g prime of x. So since f of x is tangent of 3x, the derivative of tangent is secant squared. So we know that f prime of x is equal to secant squared of 3x times the derivative of 3x. So our f prime of x is equal to secant squared of 3x times the derivative of 3x is just 3. So it's times 3. And that 3, we can just factor that out to the front. So your f prime of x is equal to 3 times secant squared of 3x. All right. Any questions on that one? Okay. So usually after a couple of these, you can kind of pick up the pattern and knock them out pretty quickly. All right. So let's say, for example, if we wanted to find the derivative of h of x is equal to cotangent 3x to the 4th power minus x squared minus 1. Okay. So remember, we know that the derivative of cotangent of g of x is equal to negative cosecant squared of g of x times the derivative of that g of x. So that means our h prime of x is going to equal negative cosecant squared of 3x to the fourth power minus x squared minus 1 times the derivative of 3x to the fourth power minus x squared minus 1. So our h prime of x is going to equal negative cosecant squared 3x to the fourth minus x squared minus 1 times the derivative of 3x to the fourth power. Using the power rule, we're going to bring down the 4. So 3 times 4 is 12 times x to the power of 4 minus 1, which is 3. Minus the derivative of x squared. Again, using the power rule, we're going to bring down that 2 times x to the power of 2 minus 1, which is just to the first power, so we can leave that. Minus the derivative of 1 is 0, so that just disappears. Okay. So you could leave it like that, or because you have that negative out here, you could distribute that negative to both of those terms. So our derivative will be, that becomes negative 12x to the third power plus 2x times cosecant squared of 3x to the fourth power minus x squared minus 1. And again, Newton might take it with the negative out here. Don't know for sure. So, like I said, always helps to have a backup. All right. Any questions on that one? Excuse me. All right. Now the next one can be a little bit tricky. So what if we wanted to find the derivative of f of x is equal to 3 times sine of x to the fifth power? Now, the easiest way to approach these is to just rewrite it. So you can rewrite this as sine of x to the fifth power. So that means your f of x can now equal 3 times sine of x to the fifth power. Which means you can apply the chain rule on this one. Okay, so your f prime of x is just equal to 3. And we apply the chain rule, so we bring down the 5. So 5 times sine of x to the power of 5 minus 1 times the derivative of sine of x. So it means our f prime of x, and we can go ahead and multiply this 3 times 5. And that gives us 15 times sine of x to the 4th power times the derivative of sine, which is cosine. So we can leave it like that, or we could rewrite it in a more familiar notation. So f prime of x is equal to 15 times the 4th power sine of x times cosine of x. All right. Are there any questions on that one? Okay. Now, there are some where you actually have to apply the chain rule twice in the same problem. This one, you only had to apply it once. But let's say we wanted to find the derivative of h of x is equal to cosine squared of 2x to the 4th power minus 2. So just like we did before, we're going to rewrite this. So cosine squared 2x to the 4th minus 2, we can rewrite it as cosine of 2x to the 4th minus 2. And that whole thing squared. Okay, so we now have h of x is equal to cosine of 2x to the 4th power minus 2, and that entire thing squared. Okay, so now we can go ahead and apply the chain rule. So your h prime of x is equal to, we take the power rule of this whole thing, so we bring down the 2. So 2 times cosine of 2x to the 4th minus 2 to the power of 2 minus 1 times the derivative of what's inside. So that's times the derivative of cosine of 2x to the 4th power minus 2. Okay. Now this is a cosine of some function we'll call g of x, which means we have to apply the chain rule again to this one. So your h prime of x, this factor is pretty straightforward. We're done with this one once we simplify it. So 2 times cosine of 2x to the fourth power minus 2. So the power of 2 minus 1, and I'll just go ahead and put it to the first power just to keep the steps up, times the derivative of cosine of 2x to the fourth power minus 2. Well, we know the derivative of cosine is negative sine. So that becomes negative sine of 2x to the fourth power minus 2 times the derivative of 2x to the fourth power minus 2. Okay, so again, the chain rule was the only way we could find the derivative of this, and it was the only way we could find the derivative of this one. Well, not the only way, but by far the least, requiring the least amount of work. Okay, so your h prime of x is equal to 2, and cosine of 2x to the fourth power minus 2 to the fourth power, to the first power, is just cosine of 2x to the fourth minus 2. So 2 times cosine of 2x to the fourth power minus 2 times negative sine of 2x to the fourth power minus 2 times, or you can put the little multiplication dot or the parentheses or both, whichever one. The derivative of 2x to the fourth power. So again, using the power rule, we bring down the 4. So 2 times 4 is 8 times x to the power of 4 minus 1, which is to the third power. Minus the derivative of negative 2 is just 0. So we don't even have to put minus 0. We just leave it as this. Okay, so since we know all of these are multiplied, we can simplify this. So we can multiply this 8x to the third power and this negative 1. I'll put it underneath it because they have a little more room under it. So we have our 8x to the third power, and we have this negative 1 here. And we have 2. So our h prime of x is equal to 8 times 2 times negative 1, well, 8x to the third, which is negative 16x to the third power, times cosine of 2x to the fourth power minus 2 times sine of 2x to the fourth power minus 2. All right, any questions on that one? All right. Okay, so that's it for 3.6. Let me see if I can. Go. And go ahead and get started on section 3.7. Section 3.7 covers the derivative of an inverse function. So we're going to do a quick review of inverse functions. Okay. So we know that an inverse function exists if and only if, again, you'll see that every once in a while, one, that a function is one-to-one. Which means that every x value corresponds to one y value and every y value corresponds to one x value. Okay. So if you plug in x equals 4 and you get 7, you can't plug in x equals 5 and get 7 again. And 2, the function is monotonic. Which means it's either strictly increasing or strictly decreasing. Okay, so let's do a quick example. Hopefully it looks familiar because it should have been, well, I'm pretty sure it was covered in your either pre-calc or intermediate algebra or college algebra. But like I said, if you're not using it all the time, it's really easy to forget. So let's say, for example, you want to find the inverse function of f of x is equal to the square root of 2x minus 3. So the steps for finding an inverse function is we're going to replace f of x with y. That gives us y is equal to the square root of 2x minus 3. Brings us to our second step. I'm going to interchange your x. and y. So instead of y is equal to the square root of 2x minus 3, we're going to have x is equal to the square root of 2y minus 3. So every x becomes y and every y becomes x. And third, we're going to solve for the new y. It's not the official name of it, but that's what I always call it, the new y. So we're going to solve for the y after switching them. So if we have x is equal to the square root of 2y minus 3, we're going to go ahead and square both sides. Okay, so we have x squared is equal to, the square and the square root cancels out. That just leaves 2y minus 3. So if we add 3 to both sides, that's x squared plus 3 equals 2y. So if we divide both sides by 2, we know that y is equal to x squared plus 3 divided by 2. And that new y is your f inverse. Goes x squared plus 3 divided by 2. Okay. Now we can prove that that is the inverse. And this proof is very important to our actual derivative of an inverse function. And we know that if we take the compound function of a function and its inverse, the inverse and the function cancel each other out, leaving just the argument x. Okay, so if we take the function of our f inverse of x, well, we know that our f of x was the square root of 2x minus 3. So if we replace the x with f inverse, that's the square root of 2 times the f inverse of x minus 3. Okay, well, the f inverse of x, we know that's x squared plus 3 divided by 2. So that means we're going to have the square root of 2. That f inverse of x, we're going to replace that with x squared plus 3 divided by 2 minus 3. we can see here the 2's cancel each other out. Anything divided by itself is just 1. So that gives us the square root of x squared plus 3 minus 3. Well, the plus 3 and minus 3 equals 0, so they cancel each other out, which leaves us with the square root of x squared. And the square and the square root cancels out, leaving us with just x. So we know the compound function is always equal to whatever your argument is, which is x. Right? So what if we let f of x be a function that is both differentiable and invertible, which means the derivative exists and the inverse exists. And we know that f inverse of x represents the inverse of f of x. Okay, so as long as we know that the derivative of f inverse of x does not equal 0, then we know that the inverse derivative of x is equal to 1 over the derivative of the inverse of x. Okay. Now, just a reminder that f inverse of x does not equal 1 over f of x. That's just a notation. So okay, so it's not like if you have 3 to the power of negative 2 equals 1 over 3 squared, or 3 to the power of negative 1 equals 1/3. It's not like that. It's not actually raised to the power of negative 1. It's just, like I said, a notation. Oops. Here we go. Okay. So the proof is pretty quick, so we can go ahead and go over the proof on this one. Okay. So we already know if it's an inverse function, then x is equal to f of f inverse of x. We know the function and the inverse cancel each other out. Okay. So we take the derivative of both sides. The derivative with respect to x of x is equal to the derivative with respect to x of f inverse of x. a little bit. Okay. Now for the left side, we know the derivative of x with respect to x is just 1. Now on the right side, we're actually going to have to use the chain rule. So that derivative is equal to the derivative of the whole thing, so f prime of f inverse of x, times the derivative of what's inside. So the derivative of f inverse of x. Okay. So if we divide both sides by f prime of f inverse of x, these two on the right will cancel each other out. So we know that the derivative of f inverse of x is equal to 1 divided by f prime of f inverse of x. So I'm just going to flip them around. So the derivative of f inverse of x, or you could just see it as f inverse prime of x. Make that prime a little clearer. Is equal to 1 divided by f prime of f inverse of x. All right, so let's say, for example, if we wanted to find f inverse prime of a for f of x is equal to negative 4x minus 1, when a is equal to 7. Okay, so first thing you have to do, well, we're going to plug in that 7. So we want to find f inverse of 7. Okay, so we can do that because we know that if we're looking for f inverse of 7, it's going to equal some value that we will call x. So if we take the function of both sides, so that's f of f inverse of 7 equals f of x. Again, we know the function and its inverse cancel each other out. So you have 7 is equal to f of x, or just f of x is equal to 7. So f of x is equal to 7. We already know our f inverse of 7 is equal to x. And from there, our f of x, oh, actually, I'll put that over here. F of x is equal to negative 4x minus 1. Okay, so if f of x is equal to 7, that means that 7 is equal to negative 4x minus 1. So if we add 1 to both sides, negative 8 is equal to negative 4x. So if we divide both sides by negative 4, we know that x is equal to negative 2. So we can take the fact that we know x is equal to negative 2 and the fact that f inverse of 7 is equal to x and just say that f inverse of 7 is equal to negative 2. So now that we have our f inverse of 7, we know that f prime or f inverse prime of x is equal to 1 over f prime of f inverse of x. Okay, so that f inverse prime of x, we're looking at x is equal to 7. So at x is equal to 7, we know that's f prime of f inverse of 7. Well, luckily for us, we know the value of f inverse of 7, which is negative 2. So we know that this is going to equal 1 over f prime of negative 2. Okay, well, we have to find f prime of negative 2 now. And we'll do that right here on the side. So if f of x is equal to negative 4x minus 1, you know that f prime of x is equal to negative 4. So f prime of negative 2, since there's no x values to replace in the derivative, is still just negative 4. So we know that our f inverse prime of 7 is equal to 1 over f prime of negative 2, which is negative 4. Or you can rewrite it as negative 1/4. Yeah, I'll write both ways. And that's your answer. All right. Any questions on that one? All right. So let's say, for example, if we wanted to find f inverse prime at negative 7, when f of x is equal to 3x to the third power plus x squared plus x minus 12, if it's given that f of 1 is equal to negative 7. Okay, so if it's given that f of 1 is equal to negative 7, now we're just going to apply f inverse to both sides of the equal sign. So that gives us f inverse of f of 1 is equal to f inverse of negative 7. So again, we know the function and its inverse cancel each other out, leaving just the argument 1. So we know that 1 is equal to f inverse of negative 7. Or we can say f inverse of negative 7 is equal to 1. Okay, so to find our f inverse prime, we know that f inverse prime of x is equal to 1 over f prime of f inverse of x. Okay, so we're looking for f inverse prime of negative 7. So that means our f inverse prime of negative 7 is equal to 1 over f prime of f inverse of negative 7. Okay. So again, luckily, we know f inverse of negative 7. So we know that this is just equal to 1 divided by f prime, and that f inverse of negative 7, we just replace that with 1. So again, we have to find f prime of 1. We know that f of x, so give that a little more room. Here we go. Know that f of x is equal to 3x to the 3rd power plus x squared plus x minus 12. We know that f prime of x, using the power rule, that gives us 9x squared plus 2x plus 1. Which means that f prime of 1 is equal to 9 times 1 squared plus 2 times 1 plus 1. So f prime of 1 is equal to 12. So that means our answer, once we replace our f prime of 1, is just 1/12. All right, any questions on that one? Okay, so we will go ahead and stop there, and we will finish up 3-7 on Monday. I have to remember what day it is. The day off kind of throwing me a little bit. All right, so if you have questions, of course, stay and ask away. But if not, I will see you on Monday.
Is the exam on Saturday or tomorrow? You said one thing, but then I said another.
All right, you too. Let me double check. Because it's due Friday, but always off for a 1-day grace period.
Oh,
So that's
okay.
why it says Saturday as the due date.
Okay.
Yep, I just want to make sure that it's where it should be. That's right. Yep, that's it.
Thank
All
you.
right, you're welcome. Do.
Have a good weekend.
All right, you too. Oh, bring that up. Oops. Oops. Will it help if I turn this off?